Hi, my name is Makoto from Johns Hopkins University, and I am part of a biomedical engineering team that has redesigned the punch biopsy procedure. We are working closely with the professors in the biomedical engineering department, along with our clinical sponsors from the Johns Hopkins Dermatology Department, Dr. Sewon Kang and Dr. Timothy Wang.
Skin biopsies retrieve a specimen of skin that is examined by a pathologist to diagnose skin disorders. In the U.S. alone, 3.8 million skin biopsies are performed annually, and the most common type to retrieve a full-thickness sample is the punch biopsy. In working with dermatologists, we have identified the following problems. Firstly, there is no way for the physician to regulate the depth of the punch when it is rotated into the skin, leading to possible damage to underlying arteries and nerves. Secondly, when the sample is excised in a crude method with scissors and forceps, the integrity of the skin sample is at risk. Finally, the suture phase is the longest and presents the most risk to the healthcare provider and patient. All the instruments used must be autoclaved in a process that takes more than 2 hours and brings the total procedural cost to approximately $50. We have gone through several iterations to refine our device. In our preliminary prototype, a steel wire is used to constrict the skin sample. However, human skin proved to be tougher than we thought. We realized we needed a shearing motion, so we used 2 different size spools for our second prototype. Our clinical sponsor requested a vertical rotation, so we came up with this design, which we dubbed the pizza cutter design. Our final prototype incorporates the shearing and a diamond wire in a nice compact design. We used a diamond wire because it provided an uneven surface to cut through the tough texture of human skin. Our handle doubles as a spool, which is housed in the shaft. We used an adjustable hub as a depth regulator and a specially designed blade for a diamond wire. Here we see the depth regulator and the lock being moved into the correct position. The blade is rotated into the skin lesion. Once the hub prevents further movement, the handle is spun to create the shearing motion of the diamond wire to sever the skin sample. The sample is collected within a blade because it has been designed to be narrower in cross-section at the top so as to fit the sample in a tight space. Finally, the wound is closed using a steri-strip instead of a suture. We first tested our device on skin substitute, which is used by residents to practice procedures. As seen here, we were able to cut through the skin substitute with ease. Next, we moved on to pig's foot, found to be even tougher than human skin. PDMS was also used to show that our device cuts the skin sample in a horizontal plane. Finally, in Dr. Wang's lab, we used discarded human skin sample to give the most accurate testing so far. Our next step is to carry out cadaver testing and obtain approval for clinical trials.
Our redesigned procedure reduces the cost by about 70% and is a simpler procedure for the dermatologist. We believe that it is safer due to improved regulation and a better overall experience for the patient. Working on this project for over a year has led to special bonds within the team, and we have also filed for a provisional patent. By making changes to a classical procedure, we hope to improve the experience for both patients and physicians. This was just a short video on our journey. For more detailed presentations, please click on the link in the description below.